All right, cool. So my name's Adam Czerepinski, and this is a talk about the Elixir programming language, which I want to get front and center that I am new to this language. I'm just learning it, and I'm really excited about it. So I'll share one of the things that's sort of one of the basic things of the language, which is pattern matching. So I'll be giving a really brief overview of the language itself, and then more specifics on pattern matching. So what is Elixir? It's a new language, new as in the last few years. It's a functional language that compiles to bytecode for the Erlang virtual machine, also known as Beam or OTP, lots of acronyms that all kind of mean the Erlang virtual machine. And it's pretty much good at the things that Erlang is good at, which is massive concurrency. So a little background on Erlang. It was developed by two engineers at Ericsson a long time ago, I think around 30 years ago, like before the web. It wasn't a web programming language. And what the phone system needed was something that would have 100% uptime, be able to handle hundreds of thousands or millions of concurrent processes. And so that's what Erlang is and what it's good at. This all hit my radar, I think mostly because of articles about WhatsApp and how they were able to handle hundreds of millions of users with a really small engineering team, no outages, all that kind of stuff. And I was aware of Elixir specifically because Jose was a Rails core team member, so I kind of knew who he was from the Rails community. He wrote the Rails equivalent of Tankoff, so the authentication library that people use, he wrote that before he wrote this language. And so my impression is that most of the people using Elixir today are people with a Ruby background or people with an Erlang background. So it extends the Erlang language, it adds metaprogramming, macros, it adds some niceties, better tooling, better documentation compared to Erlang, and it maintains the same performance characteristics. So here's what I want to talk about today, the equal sign, which is the match operator, and it asserts equality. So the equal sign can be used to assign a variable or bind a variable, but that's sort of a side effect of making a match complete. So I'll go into what that means as we go through examples here. So here's a very simple example where I say that a list is equal to this list, 1, 2, 3. And I'll talk a little bit about lists in Elixir. They are true linked lists. So the head of this list is 1, and the tail is 2, 3. And then 2, 3 is itself a list where the head of the list is 2, and the tail of the list is 3, and the list 3 has no tail, or a tail of 0 length, or however you want to say that. So there are other data structures available. This is probably the one I see the most when I look at code. Like you do a lot of recursion in Elixir, and the linked list seems to be a really good way to do it. It takes linear time to access the list, so it's really great if you want to always be accessing the head of the list and then separate the tail from the head. But if you want to access element n, it takes longer than with like a tuple, for instance, is another data type that you can access directly, but I won't be going into tuples much today. But anyway, there are other options, but that's what a list is. So in this case, I assert that list is equal to 1, 2, 3, and because list is unbound, it can match anything, and that works out okay. And then I say that ABC is equal to list, and because list is a list with 3 elements, as is ABC, that match works just fine. And then at the end of this 2 lines of code, A has the value 1, B has the value 2, and C has the value 3. The underscore is like a wildcard, so you can match this pattern by saying 1 underscore underscore, and that is indeed equal to 1, 2 tacos. So given that it can match anything, just basically the pattern has to, like the number of elements has to match in order for that to be okay. You can match on head and tail like this. So at the end of this expression, head will be equal to 1 and tail will be equal to 2, 3. And then if you try to do a match that doesn't work, you blow up. So you get an error message like this. So in this case, if you're saying A is equal to tacos, A can't also be equal to burritos, so that's a match error. Like a variable has to be constant throughout the entirety of the match. And then, so variables can be rebound unless you use this pin operator to specify that they shouldn't be. So if taco preference is a variable pointing at with guac, you could otherwise rebind tacos to be hold the guac, but with the pin operator you'll blow up if you do that. So that's a way to get specific about how to handle reassignment. And so that's an overview of pattern matching, and its usefulness is apparent when we look at how you use it in function definitions. So this example right here is FizzBuzz, that kind of like intro coding challenge that I anyways learned when I was first learning my first languages. So this is the syntax for anonymous functions, and on the next slide I'll show how that contrasts with named functions. I know this is a little unclear because I assign them to a variable, so it looks like they have a name, but it's really an anonymous function assigned to a variable. So the way that you would call this is by calling buzz. So the one at the bottom of the page is the one that actually does something. And when you call buzz, it takes an argument, n, and with that argument, it sends the remainder of n in 3, the remainder of n in 5, and n up to the other function. And then, so the function at the top, the one that's assigned to fizz, is where we see the pattern matching. So it'll check for a matched pattern in order on all these lines. So the first thing it'll check for is whether the result of buzz is equal to 0, 0, anything. So basically, if the number you pass in results in 0 when you take the remainder of that in 3, and so forth, it'll match that top line and return FizzBuzz. And if that match isn't met, it'll check the next line to see if buzz returns 0, whatever, and so forth. Is that pretty clear, like how the matching works? So this kind of takes the place of if and else conditionals, where basically right at the onset of a function, you check the inputs to see if they match a pattern, and then only use that version of the function if the inputs match a pattern. Here's like a really similar thing, but with named functions. So named functions have to be namespaced in a module. And as far as I can tell, like modules just control scope and namespacing, so they're not expensive to use or anything like that. So here's a module factorial that contains 2 methods, or 2 functions, and they both have the same name. It's totally fine to have multiple functions with the same name and that have different patterns that they might match. So if you call of, like factorial dot of 0, it'll match that first one and it'll just return 1. But if you call factorial dot of some other number, it'll match the second one. And so let's say we pass in 5, it'll match that second function, which recursively calls itself until n minus 1 is 0, in which case it'll match the top function and return times 1. So that's a really basic example. And like I said, it's a normal design pattern in Elixir to have the same function just redefined with different patterns. Alternatively, there's a syntax for functions that fit on one line at the bottom there. And this is the thing that Highlight.js doesn't handle well, so I'm just showing it one line at a time, but probably the bulk of the code on this page idiomatically would probably belong in the one-line format, like at the bottom. Guard clauses are another conditional type logic you can put on a pattern. So both of these versions of on take an argument, which is just a variable, so anything would pretty much match it. But here we say, if the thing passed in is exactly Monday, then Mo Monday. And if the thing passed in is Tuesday, then we got Thai Tuesday. So So this is an example of using the same arity, the same pattern basically, but with an extra conditional. And speaking of arity, so technically functions are defined by their name and their number of arguments that they take. So count with 2 arguments and count with 3 arguments are totally different functions. Elixir doesn't see any similarity between those 2 things, but as a don't be a jerk kind of approach, if you're naming functions the same name, they should be very closely related. So in effect, it's another version of pattern matching, where you can have a function that basically does the same thing but takes more or fewer arguments, and you can kind of group them together like that. And again, the way that you would call this is arity.count. You need to prefix the module name before the function name unless you're in that module. And then this is sort of the last thing I want to show, and it has nothing to do with pattern matching, but it's just one of the things that I like about Elixir that I wanted to kind of show, is the pipe operator works pretty much the same as it does in Bash, where it takes the result of a function and passes it as the first argument to the next function. So in this case, giant taco equals, I mean, these are all functions that presumably exist somewhere else. So you take your burrito tortilla, and then you pass the result of that to add rice. You pass the result of that to add chicken, and presumably chicken is a function that takes 2 arguments. So the first one would be whatever was passed by the pipe operator. The second one is the one you specify in parentheses. And then all of that would get passed to the cashier. So you can compose your function calls in a way that reads top to bottom in a very, to me, in a very clear way. I like that a lot. And then finally, I've got some resources. These are all links. Of course, whether you're in the room or watching this video, you can't click on them, so I'm sorry about that. But they, for what it's worth, they're links. But elixirlang.org is the official site of the language. It's got a tutorial there. ElixirConf was this month. It was really recently, and there are a lot of really great videos about different aspects of and use cases of the language on that site. Elixir cheat sheet. Oh, I should throw a shout out to Dave Thomas's book, Programming Elixir. That's where the cheat sheet is from, and where most of my knowledge about Elixir at this point comes from. Nerves, I wanted to mention, is a Linux distribution that is extremely small, around 18 megs uncompressed, and it's developed for Raspberry Pi and BeagleBone to run. It's basically something that boots up in like 5 or 10 seconds directly into the Erlang virtual machine, so you can do embedded Elixir or embedded Erlang on it. And then Phoenix is the popular web framework for making web apps with Elixir. So those are all the resources I would recommend if you want to know more about the language. Any questions? So I guess WhatsApp is probably the big example of what it's for. So if you haven't used it, WhatsApp is like a text messaging type app. And the use case there is we need to be able to handle almost infinite number of text messages all at the same time. So this is something that needs to be able to scale with massive concurrency. Distributed systems is another big thing. If you want to be able to run your app off of a large number of computers, it's very well tailored to that. I mean, I've seen people do blogs and simple apps in Phoenix and report very good turnaround times, in milliseconds in terms of page rendering. So it's fast. It's fast at things that would be slowed down by concurrency issues. I haven't seen any really great examples of what people are doing with the nerves thing with embedded Elixir yet, but I'm looking forward to checking out or trying to find what people are doing with that. All right, so that's an introduction to Elixir. Thanks for listening. Thanks for watching. And that's it for now.